Hello guys, in today's chapter we're going to talk about Newton's laws of motion. We started this chapter previously, but I'm going to remind you about the first law today, and we will continue the second and the third law in the next lessons. So Sir Isaac Newton, an English scientist and mathematician, famous for his discovery of the laws of gravity, also discovered the three laws of motion. So the three laws of motion were discovered by Isaac Newton, who was a scientist and a mathematician. Newton's first law. Sorry. Newton's first law states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. So, meaning, basically, an object will keep doing what it was doing unless acted on by an unbalanced force. So, if the object was sitting still and it is not moving, it will remain still. And if it was moving at a constant velocity, it wants to keep moving at the same velocity. So, an object wants to keep on doing what it's doing. If an object is at rest or standing still, it wants to stay still. If it is in motion, it wants to stay in motion. It takes a force to change the motion of an object. So in order to change the motion of an object, I need a force. So if an object is standing still, it will stay still unless a force change its motion. For example, a ball that is standing still on the ground will take a force to make it start moving. And if it was moving at a constant velocity, it wants to keep moving at the same velocity unless there is a force that will change its motion. Newton's first law is also called the law of inertia. Inertia means it is the tendency of an object to resist the changes in its state of motion. So, inertia means that an object, any object, any mass, has a tendency to stay at its current state of motion. Meaning, if it is at rest, it wants to stay at rest. If it is in motion, it wants to stay in motion. The first law states that all objects have inertia. The more mass an object has, the more inertia it has. So, the heavier an object is, the more difficult is to change its motion. Meaning, a heavy object has more inertia than a light object. So, I need a greater force to change the motion of a heavier object. What is meant by unbalanced force? Unbalanced force means, first, if I have a book, suppose this is a physics book that is standing on a table, the gravity pulls downward the book and the table pushes the book upwards. So the book is under the effect of two forces, gravity or weight and the normal force from the table that is pushing it upward. As we can see that the force that pushes upward is equal to the force that pushes downward, and they are opposite, so the two forces are opposite and equal. So the net force on the book is equal to 0. So the book will not change its position because the forces are balanced. If the forces on an object are equal and opposite, they are said to be balanced, and the object experiences no change in motion. If they are not equal and opposite, then the forces are unbalanced and the motion of the object changes. So, in order to change the motion of this book, I need to exert an unbalanced force. For example, if I push the book from this side with a force, it is an unbalanced force, so the book will start moving to the right, since it is under the effect of an unbalanced force. But if there are two forces from left and right that are equal and opposite, then the forces are balanced and the book will not change. Some examples from real life. Let's take a soccer ball that is at rest. Since the ball is at rest, so it wants to stay at rest. It will not change its position unless it takes an unbalanced force of a kick to change its motion. So the ball will not move because it has inertia, but it will move only if there is an unbalanced force, for example, a kick. If I kick the ball, it will move. Or two teams are playing tug of war. They are both exerting equal force on the rope in opposite directions. This balanced force results in no change in motion. So if the motion of the force that is pushing to the right is equal to the force that is pushing to the left, the rope will not change its motion. Newton's force law is also called. Okay. More examples from real life. Suppose a powerful locomotive begins to pull a long line of boxcars that were sitting at rest. Since the boxcars are so massive, so the train here, I have a train and it's pulling a boxcar. Since the boxcars are so massive, means they are so heavy, they have a great deal of inertia and it takes a large force to change their motion. So I need a very large force to change the motion of each box. Once they are moving, it takes a large force to stop them. Now, if they start moving, they want to keep on moving. So in order to stop them, which means I'm changing their motion, and since they have a large inertia due to their large mass, I need a large force. So a large force is needed to change the motion of large objects. Another example, on your way to school, a bug flies into your windshield. Since the bug is so small, it has a very little inertia and exerts a very small force on your car. So small that you don't even feel it. So if I'm driving in a car and a fly hits the glass of the car, I will not experience any change of motion in the car since the fly has a very light mass. If objects in motion tend to stay in motion, why don't moving objects keep moving forever? So, as we know, that object in motion wants to stay in motion. But things don't keep moving forever because there are almost always an unbalanced force acting upon it. For example, a book sliding across a table slows down and stops because of the force of friction. So, if I push a book on the table, it wants to continue on moving, but the unbalanced force, which is friction, causes the motion of the book to slow down and stops. Another example, if you throw a ball upwards, it will eventually slow down and fall because of the fall of gravity. So here friction is the unbalanced force in the case of the book, and the gravity is the unbalanced force in the case of the ball. In outer space, for example, I don't have gravity and I don't have friction. So, if a rocket ship launched with a certain speed and direction, it would keep on going in the same direction and at that same speed forever. In outer space, I don't have an external forces or unbalanced forces such as friction or gravity. So, any object that is moving in outer space, it will keep moving in the same direction and at the same speed forever unless it hits something which exerts an unbalanced force that makes it change its position. Okay guys, this is it for today. Next time we will continue in Newton's second law. Stay safe and good luck.